Welcome to Sandown Bay in the Isle of Wight UNESCO World Biosphere Reserve. I'm Nigel from Artecology and this is Science Beach. So Artecology has been working in the field of eco-engineering or nature inclusive design since 2013 and this is the area right next to our studio where we run various tests and research and development of the things that we make, in this case vertipools. And what we're going to look at today is a process that we call Artecology CoCreate, and it's a bit different in the sense that it invites ordinary folks to join us on this quest to make the best eco-engineered objects that we can. These two vertipools here are a test and control, or the other way around. That's the test and that's the control. And inside this vertipool are some small ceramic artifacts that have been made by communities, and they're being tested against the control to see which one works best. So these vertipools that you can see here are part of a test that we ran with the University of Plymouth last year. The test continues, but we got some amazing data that showed that the vertipools that have the CoCreate elements in, these ceramic pieces, function 3 times better than those vertipools that don't have them. In other words, we saw 3 times the amount of mobile life in the vertipools that have the ceramic elements compared to those vertipools that don't have them. So we're back in the Artecology studio. We've just hopped across the road from Science Beach, and this is effectively what we were looking at down on the beach. This is an S-type vertipool. S stands for Sandown, so these things are always named after the first place that they were deployed. First S-type vertipools were deployed back in, I think, something like 2015, and this is an S-type vertipool that's been enhanced with CoCreate elements, and you can see these beautiful ceramic elements that have been made by ordinary folks. There's a very good reason for working this way, and that's what we're going to talk about next. So right from the start of this journey for us, back in, that goes back over a decade, the science that has come out of our work and the work of others has all said the same thing. Every academic paper that's ever been written about eco-engineering says that the more texture, pattern, form, the more structural complexity you can get into these objects, the better they work for wildlife. And so we've really run with that idea. And because of who we are, the type of organisation we are, we're a not-for-profit that works with people as well as wildlife. We've developed this way of working that just uses small amounts of clay. This is a grogged clay to make these little artifacts. So what we do is we just give people these in a workshop scenario. We give people a piece of clay about that size and not a huge amount of instruction, a little bit, but just to sort of suggest the kind of shapes and things we need. And some tools. I mean, the tools can be really simple, as something as simple as a ballpoint pen, and just creating pattern repeats, like this, is a really great way to produce this sort of micro texture, micro pattern and form that produces these highly bioreceptive surfaces. And what we've discovered when you do this is you get this amazing array of different shapes, patterns and forms. I mean, look at that, just beautiful. Layer upon layer of structure, and then a hole through the middle. Tubes and holes are really hard to make using any kind of technology, really, but people's hands are perfect for producing objects like this. And we know that they work. And then it's just a case of finding ways to embed them into structures like vertipools and other things. So our collaborations don't just start and stop with working with communities and the public through the CoCreate process, but we also work with other eco-engineering organisations like Cubex, who make these amazing ultra-high performance concrete objects. They work in the field of architecture mostly, but they're branching into eco-engineering, and we work very closely with them now because they can do things that we just can't. So they produce these beautiful geometric shapes, and then we're able to use the co-create process, working with people, to bring real complexity to the interior of these things. This is a rock pool, this is a tide pool, and it has the most extraordinary complexity in its interior. Let's take you through the process of how we do this then. We've got a big old box of co-created elements made by, in this case, the people of Portsmouth, ordinary folks. This piece I've selected to go into this sea hive pool, and to do that I'm going to mix up some concrete, and then we're going to set it in to the vertical just like this. It's very therapeutic doing this sort of work, and we've found that those community groups that we work with have that same experience, and it's an important part of what we do. These issues that we're working with are big issues, big world issues, the biodiversity loss, mass extinctions. All of those things are really difficult for folks to grasp. But when you put a raw material in the hands of people and they're able to do something positive, to find ways to actually start to solve some of these really big issues, but in a very tiny way, it has a really positive beneficial effect on people's health and well-being. And that's the realm that we're moving into now. It's probably the sort of least well-known aspect of eco-engineering, but we think is really, really important.